like my toolbox, Nick?
I do.
Yeah?
It works.
The tool tray. I should put a rope on it, put it around my neck. Like, you know, I feel like a bus boy.
It would be like
that'd be
at baseball games.
I should get a bus tub. All right, so we are going up to the mill. We got to do a quick project. I hope it works.
And we have to do it quickly because there's a thunderstorm coming.
Yeah, we got rumbling in the distance. We got our two crew chief members, Maddie and Carmen, helping us out. So what we're doing, I've been meaning to do for a while. Let me show you what I have. I'll show you the situation on the mill. So usually I come up to the mill and I get a cordless drill like this one here. And I have an end here, which is the end of a ball screw. And it's getting a little rust. I actually haven't used my mill in a while. But then I put the drill in high torque mode for two reasons, the strength and the speed of the drill. So I get this thing on here, tighten it up. All right, and now the drill is here. If I put it in reverse, it will raise. Holy cow, what's going on here? Oh, is it locked?
It's locked.
Yeah. My fault. Okay. All right, that's going down in when forward goes down. If I put it in reverse, it goes up. And it goes up nicely. I like using the motor to raise the blade up and down. So the problem is, it's actually not going down right now. Sometimes when using the mill, this thing will spin crazy out of control. I just stopped it from doing so. But an earlier episode, I said when your sawmill breaks, when your Harbor Freight sawmill breaks, I forget what episode number it is, but we upgraded the screw system inside here. These two things slide together and come apart to have the blade go up and down. And I improved it so well. I improved it with ball bearings versus just the brass screw, which was there to begin with. So the ball bearing system works so well that if there is pressure on the saw itself, it will unwind itself and the saw will come crashing down on you. And so that leaves you having to rely on these little locks for the whole bandsaw system on these rails. I don't like really doing that. I wish this whole thing would just balance itself out and you could pretty much put a small motor on here and effortlessly go one way or the other and it would have the saw up and down. I'm doing this so that this doesn't put so much strain on the screw that we improved on this mill in here. We're going to help it out. So to do that, what we need to do is counteract. This thing really wants to go back out that way. So we're going to add some gas struts to the situation here. I calculated how much tension is on each one of those cables. It was a ridiculous amount, more than I thought. So they only make these up to a certain pound limit. These are each 100 pounds rated. So I calculated how far the sawmill arm travels, and that's pretty much what I got here. So I got two of them, and I'll show you where I'm going to put them. Now all we have to do on the mill is find two places to put the mounts. There's going to be a screw here and a screw here. It's just like a hatchback on your vehicle. They come with these little circular screws. So if I mount one of these guys above and below, so one would be, doesn't matter which way they go, but I would thread a screw here and thread it through in here somewhere, and I would mount this guy like that. Okay, so when this thing is coming together like this, this is counteracting that process. See, I'm raising it up. That took a lot of strength from the drill. When I drop it down, it's easier because you have the weight of the bandsaw. Okay, and if I unscrew this drill from here right now, this whole bandsaw would just crash to the ground if the locks are not engaged. So that's dangerous, number one. Number two, the locks, it puts strain on that. I'm bending those and everything. So what I basically want to do is help this arm out. It really wants to compress right now, and I'm going to counteract that process by putting gas struts in between, and I'm going to counteract that compression desire, and this will push it back outward. When this thing compresses, it's going to put force back that way, and then hopefully we will solve, hopefully this thing will get pretty balanced. So we have two 100-pound struts that we're going to introduce to the system. So we're gonna try to get them installed now. This came with the struts. They're just little circular things that these just pop on and it stays there. So one goes on this side, one on this side. So we have to drill these in to the sawmill, onto that arm that separates and contracts. So we have 4 of those for each of those. So I went to the store, and what I did, I figured out the thread pattern on these is, it's metric. It's an 8mm and the pitch is 1 1/4. That means between each thread there is 1 1/4 millimeters of space, and the other one, the 8, is 8 wide, 8 millimeters wide. So this is a metric system here. So what I did, I got that, these match up, so I want to be able to screw, see, I was originally going to weld these on. I don't have a welder yet. And so what these are going to do to allow me to place this and give me some more height for clearance, and it's also kind of taking down the amount of threads that I need to put into the hole, because don't forget, like, one tube goes into the other, and I don't want to screw this in too far and have the 2 things scraping. So I got that, and then I got a way to thread them all together. I bought a corresponding 8mm 1 1/4 pitch drill bit along with the tap. So I do need to get this thing. So I'm going to drill a hole there, I'm going to tap it, and then by tapping it, this thing will be able to screw right into the metal. We are going to measure the travel of this thing. So I'm going to put a mark right here. Now the saw, I'm just going to scratch a little bit of the paint off, no big deal.
It's all the way down.
So the saw is all the way down, and there's actually some slack on the cables here. So I'm going to reverse it and put it back up now and do the opposite. I'm going to bring it all the way up. Easy, killer. Now when this thing here, it'll bottom out, but top out. Boom, right there. So I got my first mark here, second mark's gonna be down here. And here's what we're hoping. This will make sense. I know now that I can put a hole anywhere to the right of this line and put this here. I want to get it closest to that line as possible. And then we're gonna measure this arm here on the inside. Hopefully we can then get the other arm like somewhere down here where when this thing contracts, it's not going to hit the threads on the inside here. So we're going to go through those measurements real quick. It's starting to rain. We're going to go inside the shed and take this off of here real quick.
We're in the shed now.
Yeah.
John took this part of the mill off in the rain, and I couldn't record that because we don't want to get the camera wet. So now we have to disassemble further, right, John?
Yeah, so this is just the arm that the pulleys or the cables attach to on the mill. So it runs over these and this thing, and it all brings everything up and down. Go science. So, all right, there is a set screw here that we need to undo. We're putting this whole thing on. So when Meg and I did this modification to the mill, we thought in order to keep the saw up, we could put pressure on this screw. We're gonna find like a bunch of washers and like other things inside of here. And if I remember correctly, this is like borderline stripped. All right, good. That came out a lot easier than I thought it would. That's just the set screw. Now we have to get this square nut off of there. All right, I was just trying to show our min and max lines here. This is fully extended, this is fully compressed. So the furthest it would go out is right here. I got everything disassembled here. So now I took my strut, and it doesn't matter what side I use here, but I do need the end of the strut to be past this min line. So putting it there allows me to get this guy down here. So we're roughly measuring where this strut is going to end up. Now, being that it's down here, when you go to the compressed line, this bar kind of crosses over that area, and I was hoping that wouldn't happen, but it did. and that gives me a problem of clearance. This guy slips in here, and we do have wiggle room. Here. We do have wiggle room. There is some there for it to, but not enough if you look at the thickness of the pipe. And even with my nut as a spacer, that's just too much threads coming. So I'm gonna have one here and one on the other side. We'll have 2 struts all together. And I think we're going to have to space this with a couple washers so that we're only protruding about that much into the hollow pipe. We have all the mounts on, you know, the male and the female parts here. We have the 2 struts. They're going to be one on the top, one on the bottom. We're doing final assembly now. Everything has gone good so far. Let's see. Now these just click right on. Come on over. Now these, I'm putting the bigger end on the smaller square tubing so that this doesn't interfere with the wider piece. So we'll just click it on. We just did a dry fit on the mill and it's great. Nothing's interfering with anything. This strut here, this kind of rests on a plate on the mill, and this strut doesn't interfere at all. So we're good there, but the problem is, it's a small problem really. I just can't get this bolt through the holes, especially the one near the head of the strut. So I'm gonna dismount this, get this through, put the strut back on, we'll go back to the mill, and then we should be able to bolt it back on, no problem.
Starting to rain harder now.
Yeah, let's go in.
Okay.
Go ahead.
To be continued. The other one's about to pop too, John.
Really?
Yeah.
Where did I rip it out of there? Oh, you know why? You just see it interfering, right?
It's interfering.
Yeah. Well,
the inside bar is hitting it. Is that what you mean?
I think so. Really. What, this?
Yeah.
Oh, for sake. Well, you know what? It'll work with a welder.
Uh-huh.
I gotta put these in the same spot with a welder and tack it right on there. No interference. That's the way you gotta do it.
I follow you. Yeah. Well, I guess you just have to get a welder.
Huh? How about that? That's good. Okay. Unboxing. Alright, I've been eyeing up one of these dinky welders for a long time. And I was gonna get a really, you know, I should show you what's in here. Okay. Manual, quick start guide, I guess. Okay. That looks like a tip for the wire feed gun thing. Okay, a little baggie of stuff. Yay, styrofoam, my favorite. Ugh. Okay, and then we gotta, wow, this thing is very light. There we go. Cool. And that's like a soft hose. Oh, did it really come with, oh, that's nice, it's broken. Hope that doesn't matter. It gives you some starter wire. Cool. And that was in there, I guess. Good job, guys. Cool. Alright. Shows you how much they toss things around. And okay. Alright, so I got this from who else? Harbor Freight. Not ashamed to say. All their stuff has been fine for me. I ain't no fool. Alright, so believe it or not, guys, I have never welded before, and I thought I would get my feet wet by getting this really small, ultra portable 120 volt or 125 whatever welder that can do just basic things. This plugs in with standard 120 volts. Okay, boom, right in there. No special plugs or crazy amperage lines required. There's a simple grinding clamp here, or grounding clamp. So that's good. So this is just going to be in the shop. So the thing I wanted to just get used to welding, and I told Meg we were going to get a really, we weren't going to skimp. We were going to get a nice Lincoln from Lowe's. It was about 750 bucks or so. I wanted to start with this guy and see what it can do and see if I needed the bigger one. So I'm just looking to use this for like simple tasks, simple, like, you know, 1/8 inch steel, just real simple things. A lot of times I'm working on stuff and it's like I catch myself saying I wish I had a little welder so I didn't have to like drill a hole or screw something together, something like that. So I picked up one of these from Harbor Freight. It's about 200 bucks or so, if that. And I got it on sale. Came with wire. So this is it's only 15 pounds, this thing, and it's an easy flux. So all the flux and everything's in the wire. There's no shielding gas required. A lot of times you have to use argon along with MIG welders, which comes out of the gun and shields it during your weld, but this is not needed at all. I actually do have the argon, so that wasn't a worry. But refilling argon can get expensive and annoying, and usually when you need it you don't have it. And so this, the other benefit to this, I can do other things on the property. I could stick this little guy in the loader on the tractor and run around with my generator, fire up the generator and just plug this thing right into it and weld something, like if we're doing posts or if we're doing something by the mill or whatever. Pretty flexible. I do have a 240 volt outlet on the generator too, but I don't know if it has enough amps to power like a really big welder. So anyway, I'm just going to start learning about welding, and I like that this had different there's wire speeds, which is okay, so 1 through 10 as far as how fast you want the wire to come out, and then this I believe is your power. It goes from A to J, and it probably gives you a guide, a table on there showing you, depending on the thickness of your steel or what you're welding to what setting you're supposed to put this at. So that's all it is to it, how fast you want the wire to come out and how high you want that you know, the amperage or whatever, the electricity to be sent. So I'm excited. We're gonna give this thing a shot.
So now that John has his welder, we gotta disassemble the mill again.
It didn't work. I broke my rake and I thought it would be a good little test project. I've never welded before. And I want to say something. I'm gonna talk about this right here. It's one of my favorite tools. I don't have the guard for it. I know it should have a guard. I choose to use it like this still because I really like this tool and I'm used to it. I know the weight and everything and how it operates and the speed. Like, I've been using it forever. Took the guard off one time, lost it, haven't seen it since. Can't do anything about it. I could buy a new one, but I don't want to.
However, put some safety glasses on.
Give me your glasses.
How am I gonna be safe?
Well, I broke mine. Just like I lost the guard. All right, I'll go get some safety glasses on. That's fine. Do you know where,
Daddy!
Where's my Pure Romance?
I don't know, they've disappeared.
Accepting jobs. If your rake is broken and you have both parts, send it on over. And yeah, if you want John welds, here's John welds. Ready? Look at that thing. It's just cooped on there.
Oh yeah.
Hey, you know what? It works though.
That's, I mean, we weren't going for looks, right? Good job.
So I learned that it will only fire when that trigger is engaged, when it's feeding the wire. You can't just tap it. You gotta, like, so if you have too much hanging out, you gotta figure out something to do with it. Maybe carry a pair of clippers or something, but we're good.
Great.
Yeah, I think I'm ready for that.
How did the helmet work?
Oh, great.
Okay.
Works really good. Yeah, no hesitation at all. Just, it auto darkens. I mean, as soon as it starts firing away, it just gets dark. So, it also is worth noting, this thing is running from the plug, the outlet in the RV. But not only that, we have a 100-foot extension cord on that outlet, and it's powering this welder. So it doesn't take anything to run this thing. Hey, 1 for 1.
So first impression, you're happy with it?
I would buy that welder every day of the week. Yeah.
For what you're using it for?
Yeah, all I'm looking to do is like just do projects with like 1/8, maybe 3/16 steel, probably 1/8 though. Just something like that, square tubing, stuff like that. Just removed these struts, this and this, and these are fine. These are in place already down here, and they probably didn't bend because they have a lot more threads. They're more stable. I gotta remove this one. Where's the other one? Here it is. See, that's all the threads we have, so it was kind of like top heavy. It was like too much torque being put on this little ball. So we're gonna weld this whole thing now.
Show me again.
This here, this is what the strut attaches to, obviously. And then I have 2 washers, a nut, and then I threaded the hole into here, and it like just ripped it apart. It bent the threads, the whole deal. So we're gonna clean everything up, and we're gonna weld these into place, and then we're gonna remove this one and probably just eliminate the big spacers. Yeah. Okay. Definitely a learning curve, like anything else. But I mean, for unboxing the thing, plugging it in and throwing the wire on it and just squeezing the trigger, it was really easy. I just have to figure out the 2 settings working together and figuring out the speed and intensity and just overall, I guess, technique of zigzagging back and forth, the settings on the helmet. There's a lot of things that have to come into play to actually get the hang of this thing. But I imagine, I mean, I have a bunch of steel laying around, like old farm posts and things like that, the little stakes that go on the ground. I could practice with those and try to hone in on the settings. And but this was great. I mean, I got 4 bolts on there, and that's what we were trying to do, right? Oh man! All right, I gotta research. I gotta figure out what to do. I mean, it's on there, okay? That's a farmer's grade weld, right? Which means it's...
No, I think that's offensive.
Why?
Because I'm sure there's some farmers who are some great welders.
You think so? I mean, sure. Yes.
What you should call it is a
amateur weld? What should I call it?
All
right, farmers, I apologize. I know some of you are like really awesome with welders. But
how about a non-motorcycle building weld?
I don't know. Label it what you want. Look at it. It looks like it's got warts.
Let me zoom in.
Look at my weld. This one's the worst of all. Look at this.
Is that the first one you did?
I don't know. Look at it though. I mean, that's going nowhere. You could tie the Titanic to that thing. All right, Meg, let's make a resume for me. Welder, professional. Gosh.
You should let me.
Look at me! Look at this! Look at that! I painted them. They look good. It's really just to stop it from rusting. All right, what was that noise? Did you get it?
Yeah, I did.
It was weird. Now with the weight of the mill, see, these things are wanting to push it out, and this thing has tension, it's wanting to come in, so we have an opposing force. Gonna work?
You can't really tell if it's working, can you?
Well, there's no locks on it, and it's suspended.
Oh, and it's not dropping.
No.
So it is working.
It kind of goes back to this one, like if I go up a little bit like this, it kind of wants to, a little bit. See?
So is it helping?
I mean...
It's not falling on you, but...
Right.
Did you expect it to help more?
I did.
So if you were to get struts that could take more weight, could you just put them on those mounts that you welded on?
Yeah. Take 3. Back at the sawmill, I put the 100-pound struts on here, the air struts, or gas struts I mean, and it's doing a good job. I unlocked the saw so it can move freely on these rails on either side, and it is not falling down. So that's really good news. So these are working, but they're not working as good as I had hoped. And I was skeptical about the numbers I was getting from the tension scale. The tension scale, I put it on here, measured the tension on each pulley set, each cable, and I was getting crazy numbers, like 300 and something pounds, like on each, or 250, somewhere around there. I don't remember. We'll have to go back to the video. But okay, so I am simulating what it is to crank this thing up and down. Right now I'm lowering it, and gravity's helping me, so it's really easy. If I switch and go this way, I have to put a little bit of strength behind it. I'm not going to complain about it, but it could be a lot better. And I think if I double up the amount of force here on each strut, we're going to have really good results. So I hate dumping money into this project, but I've worked this hard on it. I really want it to function properly. So I didn't think these were out there, but they are. These are double of what one of these is. So this is a 100-pound strut. This is a 200-pound strut. It's longer, it has a bigger stroke, which is good news too, because this one limited, it took away a little bit of the up and down motion here. So this one is a 23, I'll link to these. These are a 23-inch strut, and the travel is more than the 8 1/4 inch that I need for the linear motion on this thing. So we are going to basically redo this whole thing. Now we're gonna just remove the nubs that I had installed previously, because these new struts are metal on the ends here, and I cannot take these things off and simply slip these things on, plus the distance is different. So what we're going to do, because of the size difference, we're actually going to be mounting these things on there. These are mounts that came with these struts, and we're going to utilize these, welding these to the frame and getting them in the position that's desired instead of getting it so tight. So I'm going to cut them off with the grinder here so that we could put the new ones on.
And as far as the length that you had to do, so if someone was replicating this, where do you need it to be?
Okay, so if you had these 23-inch struts here, the 200-pounders, I extended the arm from this point here to the end of the black 15 inches. Then I can install this, and then I'll contract it in before installing it on the saw, about a 1/2 inch. So we oriented this one that way. That one's all welded on, which I got a good bead, Meg. I
job.
I got a good, yeah. Okay, so we can't just echo or reflect and mirror it that way. So what we have to do, the distance from here to here, it would interfere when we reinstall this thing. It would bump into a part on the machine. So we flipped it around and decided to weld it this way and have the strut positioned so that it installs from like the inside here. So the thing is, this one's going to install here. We want it to go through this circular hole so it doesn't slide around on this like adjustable hole. We want it to install this way, right there. And just keeping in mind that you have bolts here, you got to check your clearances. Like that's a good like 3/4 of an inch. So I guess if you're going to be doing this and you're kind of using this video as a guide, just make sure that these mounts, make sure you have the clearance. Just check ahead of time, because I'm going to be positioning these kind of in a goofy way just so that they clear. Hello. Uh-oh. I got stuck. Okay. This is new. I got stuck.
It says gas spring struts. There's a typo on them.
Struts.
It's all right, they'll still work.
Meg, hand me.
Show me your strusses.
400 pounds of strust power.
It's pretty heavy duty.
Meg, look at me. If this doesn't work,
we give up.
I'm going to the store and I'm getting some beer and a pizza. And I'm gonna cook it and drink it and feel sorry for myself.
It's gonna work.
Ready?
Where are your wheels?
I know.
You left them down there.
Just chill. Get them. All right.
I try to remind you of things so we don't have to make multiple trips.
Okay, Meg.
Try.
All right. Now we got struts on here. That looks good.
It does look good. No interference anywhere.
Nope. Okay, got these threaded on. So these get installed first, and John was smart this time. Right, Meg?
Uh-huh.
I was smart about...
We welded these bolts in place, so we don't have to have something holding them on the other side.
Yeah, I tacked them in place, really.
What's going in?
All right, so this is my makeshift handle right now. If I let it go, okay, that's what I want.
Because you don't have the weight of the mill on it yet.
Right. So now we need to run these cables.
It's holding the weight.
Yeah.
That's what you wanted.
So I could position this wrench now wherever I mean, it kind of unthreads a little, I think this is still heavier than the struts a little bit. I mean, I'm spinning this thing around with my finger. So that kind of shows you. There still is a little downward pressure on it, but it's a lot better. Closer to where I wanted it. I think a stepper motor would be able to move that. It's doing its job. Look at that. That's cool. These things are holding the saw up. That's pretty great.
Cool.
Now, not so much pressure is needed for these things, these locks. All they really got to do is engage it a little bit, provide a little bit of locking friction for vibration when you're running the saw. And this is good. This is great. Look at that. It's holding it up. It's not slamming down. Our gas struts are working.
Good job, John. They do.
Works really good. And they're cheap as hell. But wait. If you call right now, we'll not only give you one screwy tap, we'll throw in 2 more for free. Just pay separate fees. Guard on this. Don't need the safety speech every time I use it like this. Can you put that in, please? No? You're not going to. Are you?
Don't say it's snarky.
Okay. You know what I could do?
What?
I could take that little grinding wheel, make it look good.
And then spray paint it.
Yeah, just grind it off and spray paint it. Yeah, I welded that.
Oh, John.
Gosh, that is so funny. See, real vice grips don't, like, you know.
Sorry.
This is like, oh no, I can't find my vice grip. So let's use this off-brand.
Once the shed is organized, you can have a section of real vice grips and non-real vice grips. And I'll know which ones to get.
It's like on its lowest setting and I can't even... This isn't gonna work. I gotta go get real vice grips. Glob it on there! That's my approach, just glob it on there.